Today we're moving on to 7.4, which is solving polynomial equations in factored form. So, factored form is a polynomial that's written as a product of factors. In other words, it's something times something. And factored form is nice because when it's in factored form, we can use the zero product property. The zero product property says that if you have two numbers being multiplied together and the answer is 0, then at least one of those numbers has to be equal to 0. So for example, if I have 3 times some number equal to 0, that some number would have to be 0. That's the only way it works. So at least one of the numbers have to be equal to 0. We could make both of them equal to 0. If I have two things being multiplied together equal to 0, both of them could be 0. But at least one of them has to be 0. Roots is a fancy way to say the solutions. So the roots, the solutions, the zeros, all of those mean the same thing. It means find the answer. Repeated roots is when you have two or more roots or two or more equations that are the same, two or more answers that are the same thing. So if I get two answers and they're both x equals 2, I don't have to say x equals 2 and x equals 2. I can just say x equals 2. That's kind of like if I asked you what your favorite color is. And I say, what's your favorite color? And you say, my favorite color is yellow. My favorite color is yellow. Okay, that's kind of silly. We don't need to say that. You can just answer it once. So if you get a repeated root, meaning you get the same answer 2 different times for the same problem, just list it once. All right, so if I have two things being multiplied together, which in this case I do, I have x being multiplied by x plus 5. At least one of those things has to be equal to 0 since the other side is equal to 0. So I know that either x is equal to 0 or x plus 5 is equal to 0. Those are my two options. This one's already solved. This one I just need to subtract the 5 over, and I get x is negative 5. So I have two possible answers. X could either be equal to 0 or x could be equal to negative 5. And both of those, when I plug it in, will work out. So if I plug in a 0 here and here, I end up with 0 plus 5, which is 5, but 5 times 0 is 0, so it checks out. If I plug in the negative 5 plus 5 is 0, and this 0 times negative 5 will still give me 0. So it checks out. So if I take a look at the next one, I know that either a is equal to 0 or a minus 12 is equal to 0. If I add a 12 on both sides, then I get a could either be 0 or a could be equal to 12. Go ahead and try the next two and see how you're doing, and then come back and check. Okay, so either 5p is equal to 0 or p minus 2 is equal to 0. So if I divide both sides by 5 for the first one, I get p is equal to 0. The second one, if I add a 2 to both sides, I get p is a positive 2. So again, I've got two possibilities. Either one, when I plug it in, will give me a true statement. So either one of those could be my solution. All right, number 4. So I can set either c minus 2 equal to 0 or c plus 1 is equal to 0. When I solve them by adding a 2 and subtracting a 1, I have my two possibilities of what c could be. Same thing goes for 5 and for 6. Okay, let's take a look at number 7. So now it wants us to factor it. We can't use the zero product property unless we have two things that are being multiplied together. So if we can factor our polynomial, then we're going to be able to use the zero product property then if we're asked to solve it. So to factor, I'm looking for what they have in common. So 6x squared and 3x both have a 3x in common. They both can be divided by 3x. So when I take 6x squared and I divide it by 3x, I'm left with 2x plus, and when I divide 3x by 3x, I'm left with 1. So now I have factored out the greatest common factor. So I'm looking for the greatest common factor, the biggest thing that you can divide both of those terms by. And now I have it in factored form. So in number 8, if I'm going to factor out the GCF, they both can be divided by 4, and they both can be divided by y to the third power. When you're trying to decide how much of a variable you can pull out, what the exponent should be on your variable, it's always whatever the variable exponent is on the smallest one. Because I can do y to the fourth divided by 3, but I can't do y to the fourth, I can't do y to the third divided by y to the fourth. I don't have enough to pull out. Okay. So 4 divided by 4 is 1, y to the fourth divided by y to the third is y. Remember our rules of exponents? We talked about how if they have the same base and you're dividing, you keep the base and you subtract the exponents. So we're still using those rules. minus 20 divided by 4 is 5, and y to the third power divided by y to the third power cancels out to 1, so just 5 times 1, which is 5. Try number 9 and see how you're doing on it. Okay, so for number 9, the GCF on this one is going to be 6u. They can both be divided by 6u. So 18 divided by 6 is 3, and u to the fourth divided by u is u to the third. Minus 6u divided by 6u is 1. So why do we need to be able to factor it? Well, because this next section, it asks us to solve it. We can't solve it unless we have it in factored form. The reason we can't solve it is because we've got a k squared in it. If it had just k's, then we could solve it like all of our linear equations. But this one has a k squared in it, and we can't solve that using a method other than this one. So I'm going to factor out the greatest common factor, which in this case is k. So 6k squared divided by k leaves me with 6k plus, and then k divided by k is 1. So now I have two things being multiplied together. Notice in the original problem, these two are being added together. There's not a rule that says if two things are being added together equal to 0, that one of them has to be equal to 0. That doesn't always work. It could be, but it definitely doesn't always work. So we have to get it so it's two things being multiplied together. So this times this. Now I can set each of my factors equal to 0. So either k is equal to 0 or 6k plus 1 is equal to 0. So I've got the first one's already solved. The second one, I would need to subtract the 1 over and then divide by my 6. So I would get k is equal to negative 1/6. Again, we have the word or in between it because it could be one or the other. Either one is going to work. All right, go ahead and try number 11 and number 12. Factor out the GCF and then check back in and see how you did once you solved it. Okay, so for number 11, the GCF on this one is going to be 7n. When I factor out a 7n, I'm left with 5 minus 7n, and it's still equal to 0. Now I have something times something equal to 0, so I can set each of those somethings equal to 0. So 7n equals to 0, or 5 minus 7n equal to 0. When I divide both sides by 7 on the first one, I get n equals 0. The second one, I'd subtract the 5 over first and then divide by a negative 7, so I would get n is equal to a positive 5/7. And I've got my two answers. Okay, but what happens when we get to like number 13? In number 13, it isn't equal to 0. You can't use a zero product property unless it's equal to 0. So we just need to get it equal to 0. So I need to add a 72x to both sides. Okay, so 72x and 6x squared. We have 6x squared plus 72x, and it's equal to 0. Now I can factor out the GCF. So I have 6x, and then in parentheses, when I factor it out, I'd be left with an x plus, and then this would give me a 12. Okay, so from here on out, I've got something times something equal to 0, and now I can set each of them equal to 0. So I have 6x equals to 0, or I have x plus 12 equal to 0. When I divide both sides by 6, I get x equals 0. When I subtract the 12 on both sides, I get x equals negative 12. So I've got my two possible answers. Okay. Let's do one more. Let's do number 15 to make sure you've got it. All right, so I've got to subtract the 21p over. So 7p squared minus 21p. Now it's equal to 0. And now I can factor out the GCF. So a 7p is what they have in common. When I do that, I'm left with p minus 3 equal to 0. So either 7p can be equal to 0 or p minus 3 can be equal to 0. Divide both sides by 7 on my first one, add a 3 to both sides on my second one, and I've got my two possibilities. So all of this is possible because of our good friend, the zero product property. Two things are being multiplied together and it's equal to 0. One of those things at least has to be equal to 0. So if it's not equal to 0, get it equal to 0. If it's not two things being multiplied together, factor it so it's two things being multiplied together. Take a second